Hi, my name is Robert Caruso, and I'm an IT senior infrastructure engineer with over 20 years of experience. And I just recently earned my AWS Solutions Architect Associate certification. I'm really excited to start working in AWS, and I just started to kick things off by challenging myself with a project. I wanted to see if I could build an enterprise-grade cloud architecture using all the AWS tools in the toolbox, but do it only using the AWS free tier. So that would mean I was going to use application load balancing, auto scaling, CloudFront, NAT Gateway, Route 53, Web Application Firewall, and of course infrastructure as code. So what was the goal going to be? The goal was going to be to build a web server solution across 4 AWS data centers, 2 in California and 2 in Virginia, in such a way that they could withstand natural disasters. So let's just say that there was an earthquake in California that destroyed 2 data centers. And over in Virginia, we had a tornado that took out 1 of 2 data centers. In our web server solution, our customers would continue to use the website as if nothing had happened. This is the story of how I achieved that in just my first 10 days of AWS hands-on experience. And I've broken it up into 5 key milestones. Now, I know not everyone watching this is a cloud engineer. So I built this in such a way that I explain clearly what I built, why it matters, and you can follow along even if you don't have an AWS background. Now, if you are a cloud engineer, I do have an infrastructure diagram and walk through at the towards the end of the presentation that I really do think you'll enjoy, so check it out. Thanks for watching.
For my first milestone, I built a website that could stay online even if one of its data centers went down. I started by registering a custom domain name, bobsandbox.com, that I made just for this project. When somebody visits that address, they're sent to one of 2 identical servers in Virginia that are running in one of its 2 data centers that we have set up, US East 1B or US East 1C. These servers sit behind an application load balancer, which normally distributes traffic evenly between both locations. But if one data center goes down, what it does is it routes all traffic to the healthy data center. The system scales the number of servers that are running in each data center up and down based on demand. And email alerts are sent whenever a scaling event occurs. In a real life scenario, they would go to an operations team. The website I built, it's very simple. It just tells you what the name of the server is that's running and which data center that it's running in, US East 1B or US East 1C. If you click on the refresh over and over again, you'll see it'll just keep flipping you between 1B and 1C. What I did that was to verify that the load balancer is splitting up traffic evenly and that the auto scaling is working. So what this milestone showed was that I could build a resilient, self-healing website, which is the kind of setup real-world applications rely on to stay available during outages. The next milestone was to simulate a backend server, something our web servers would connect to in a real-world application. You can think of a backend server as a database. Let's say our web server is for a supermarket and a user comes and he wants to buy eggs. He brings up eggs on the web server. The web server connects to the database back here and says, hey, how much are eggs? And then it tells the web servers how much the eggs are, displays it to our user, and our poor user faints from the price of eggs. So when we're building a backend, there's 3 things that we need to make sure of. One is that it can communicate freely with the web servers, which you can see here. And it should be invisible to the internet, so bad actors can't reach it. And it needs to initiate traffic outward, so it can do things like downloading patches. And what we do with that is we use a NAT gateway. So if you look here, the NAT gateway will block any malicious agents coming into it. And at the same time, if the backend server needs to go out to the internet, it'll let it go out to the internet safely and securely. This milestone added Amazon CloudFront, a global content delivery network and AWS Web Application Firewall for edge security. A user on the West Coast connects to the nearest CloudFront edge location using their home internet. From there, they jump onto a much faster internal AWS network that carries them the request to the data center in Virginia much faster than if they use their connection across the entire internet. At the same time, Web Application Firewall filters out bots and malicious traffic before it reaches the system. These upgrades significantly improve both performance and security, bringing the project closer to a real-world production setup. The next milestone was to implement one of AWS's most important principles, infrastructure as code, and use it to create my setup in California region. Up to this point, I've been building everything manual through the AWS console. With infrastructure as code, you define your architecture in a YAML file, like this one here below. I used a tool called Former2 to convert everything I built in Virginia into a reusable blueprint. Then I simply selected California, uploaded the file, clicked the button, and boom, AWS built the entire environment for me, exactly as it was. Everything launched perfectly, and now I had an identical setup running in 2 regions, just one step away from full multi-region routing. That brings us to our final milestone, regional routing between Virginia and California. Using Amazon Route 53, users are automatically routed to the closest region. So if you can imagine this side being Western United States and this side being Eastern, all these users here will be automatically routed to the Virginia region, whereas these users will be routed to the California region. Now, let's say we lose one of our regions. For example, say an earthquake hits California and takes both these data centers down. Route 53 will then route everybody to the Virginia region. Now, say one of these 2 data centers dies here in Virginia. Say maybe it gets hit by a tornado and there's one data center left. Route 53 will now route everybody to that one data center, and all the users will keep working as if nothing happened. So the mission is complete. I can lose an entire region and 3 out of 4 data centers, and users won't even notice. As promised earlier for our engineers, here is the architectural diagram. You can see that users here come into the Route 53 and they get routed to either one of 2 regions here. If we look at this region here, we hit a web application firewall before we hit the application load balancer. And then we have our application scaling group spread out across 2 subnets. And then we have our private backend here, which can go out through the NAT gateway to get to the internet. And we also have another bell and whistle here that I didn't mention, that if we want to get to our backend to do some SSH connection, we go in through a jump box here. And then you can see down here in the California region, we have the same exact architecture duplicated that we used through our YAML build. And then the last thing that we have here is we have an SNS queue that we use to send notifications for auto scaling and CloudWatch over to email notifications. This project marked my first 10 days of any hands-on experience with AWS, and it makes me excited to think of what I could achieve working full-time. It was incredibly satisfying to apply what I had learned studying for the AWS Solutions Architect Associate exam. Not just to pass it, but to actually build and troubleshoot real infrastructure. Over the course of this project, I focused on thinking like a solutions architect, balancing cost optimization, performance efficiency, security, and reliability, all while following best practices and documenting everything I did. I'm looking forward to learning of opportunities where I can do this kind of work full-time. Thank you for watching. I hope you enjoyed this, and feel free to reach out.